I know, but I put it somewhere else, so I'll let you guys know.
Well, why don't you just...
You remember the...
I don't remember. I have it, but I'll let you know. Alright. Does everybody have a calculator, or somebody near them has a calculator you can borrow? Alright. The mean. When you guys see the word mean, what is the definition of that? What's another word for mean? Average. Okay. Right. So the mean is the sum of values divided by the number of values. Divided looks a little weird. So the mean is when you add everything together and then you divide it by how many things that you added together. That's how you find the mean or the average of something. There are two different kinds of symbols that they're going to use to represent the mean. In your calculator, they most often use this symbol. It's a little x with a bar over top of it. We just call that x bar. That's the symbol for the mean in your calculator. In formulas, more often they use this symbol, which is called mu. It's a Greek symbol, mu. That is another way that they're going to represent the mean as a symbol. So this is more calculator stuff. This is more like formulas and stuff like that. Right? So this little grade box right here kind of explains how that works. So we're going to break down the formula. This is what the formula looks like. X bar is equal to, do you guys know what you call this little, not ellipse, sigma. It's a sigma, it's a capital sigma. Sigma means to add. Alright, so when you see the sigma symbol, it means add whatever's next to it. So they want you to add all the x values and divide by n. N represents how many data points you have. So for example, if I made up this one right here, my data was 4, 36, 10, 22, and 9, and I wanted to find the mean. I would add all of them together and divide by 5 because I have 1, 2, 3, 4, 5 data points. And your answer would be 16.2. Yes, you did. Alright, so you can do it by hand, but we're mainly going to let our calculator do it. Because you can plug in the numbers into your calculator and have it spit out everything. The mean, the standard deviation, the variance, all the important stuff we're going to be talking about. We're going to let our calculator do it. So you guys don't have to worry about doing that by hand. But understanding why that works gives you a better foundation for that. Alright, so this little guy that we just talked about, the sigma symbol, it's called sigma. It means that you should add everything that follows. That sigma is going to come back when we get to Unit 9. So you don't want to forget the sigma. So we're going to be using it in depth in Unit 9. The little xi thingy, that's supposed to be an I. That's called x sub I. And it stands for each individual data value. The I is just a counter. Right, so I here does not count for the imaginary I. They just use I to represent a counter. So you could say that x sub 1, they replaced I with 1. What does that mean? X sub 1. It's the first number, which is what? 4. X sub 2 means it's the second number, which is, okay, x sub 3 is the third number, which is 10, x sub 4, 22, and then 9. So the I just stands for index in this situation, and the index is a counter. It tells you which particular value they want you to look at. Okay? And then N stands for the number of data values. So that was kind of all the symbols in your formula. That's what they all stand for. Alright, this is how we're going to use our calculator to do the work for us. So that's why I wanted you guys to have a calculator. This is our probability and statistics unit. So we're going to be using the stat button because stat stands for statistics. So you guys are going to go in. Anytime you guys have a list of numbers, a data set, you go into stat edit. You're going to enter your numbers because there's only one list instead of two. You're just going to put them in list 1. So everybody should know how to do that. Go into stat edit and put 4, 36, 10, 22, 9, the same numbers we were working with before. You're going to enter them into list 1. This is still stat edit, stat calc. So we're going to use something differently in stat calc. So when you guys hit stat edit and put the information, now you're going to hit stat calc. And you're going to see the list that has all of your options. Normally we use like 4, 5, 6, or 7 when we're trying to find the equations. Instead, we're going to be using the first one, which is 1 bar stacks, and then push enter, and you should see all this information. Right? Remember, the symbol for the mean is x bar. That's going to be the first option there, 16.2. We found that when we did it by hand. Your calculator can do it for you. It gives you, this is the sum, the sigma x just tells you all the x values added together. So if you wanted to know what these were added together, that's 81. Sigma x squared is if you squared them all and added them together. This s thing, actually don't know what that is, but this little sigma is the standard deviation. We're going to talk about that a little bit later. And then n is 5, that tells you how many values you had, blah, blah, blah. It tells you all sorts of information. I think that might be the variance, but not 100% sure. So we don't ever use that. Alright, so it tells you a lot of good stuff in that screen. Alright, so we're going to practice with a new set of information. Our first example right here. I want you guys to go back to stat edit, clear the list, and enter this information. We're going to find the mean for this information right here. So go into stat edit, and there's a lot of numbers. Just be really careful as you're typing them in. Typically, when you guys are finding the mean, we round to 1 decimal point, or 2, depends on the direction. 45.4. Is everybody able to see that? The x bar value is 45.4. Whenever you're entering data, you need to make sure you're very, very careful that you have the numbers written correctly. Okay? Alright, we're going to create a little data set for our class here. We're going to find everybody's height in terms of inches. Do you guys know how to do that? No. Like, I'm 5'7", so you're going to take 5 and multiply that times 12, because you have 12 inches in a foot, so 5 times 12, and then add 7. Shoot, what is that? 70?
67.
Yeah, 67. So that's me, right? I want everybody to do the same thing. And then you're going to write down your data point, and then we're going to ask everybody to share it out, and I'm going to write it down. So, as we're sharing out our height data points, everybody should be writing them down. Right? Okay, whatever your height is. So if I'm 5'7", you're going to take how many feet you are and multiply that times 12, and then add on the extra inches. Okay, that's how you find it in inches.
So, you're how tall?
Alright, Anthony, what's your data point?
65.
Alright, you guys need to be writing down the information as we go. So this is me, this is Anthony, alright? Keep writing stuff down. Alright, kind of 67. 68. We're writing them down as we go. 69. Don't lie about your height. 67.
71.
Wait, what's that? You
That's cool. I'm
64.
Wait, I can't catch that up.
They're just numbers that people are saying, so if you're listening, you should be able to write them down.
Yeah.
I can't write that.
Listen.
Alright, catch up. Alright, 77.
Martin,
67. Alright, we're starting the next row.
I missed the number. Yeah, I missed the number.
You missed a number. Did you include mine? Everybody double check to make sure you have all of them.
I got it.
Just right at the end. Alright, who do the, sorry, Michaela, I didn't hear yours. Ooh, a decimal. 64.5. Make it interesting. Jonathan? Not Jonathan, sorry, Justin.
72.
Jonathan? Okay.
I was genetics.
64.
right? Oh, oh, so this is fine.
65. 4. 3. Okay. Oh, we don't know how
I have no idea.
you know what time you are?
Really?
No, I didn't know how to.
I think
Yeah,
it was 66.
You want us to guess your height?
I'll give him 60.
Wait,
Stand up. Stand up, we'll guess.
81. Oh, it's an 81 right there.
It's probably 6.
I'll give him 60.
66, maybe?
60.
Yeah. I said
67?
60.
66.5. All right.
Alright.
Wow.
You gotta do Dustin.
Make it interesting. Amy. 63.
You already have it.
And then Sandy. Okay. So this is a lot of numbers, but we're going to find the average height in this classroom. Alright? Alright, so now go ahead and enter that data. Be very careful. Enter the data into your calculator.
What? Wait, just like all of them in one column?
Yes, all of them in one column.
Yeah, so
You're the third tallest person in the class.
I know. Thanks for. I think I lost this. No. It's actually oh my god, I'm done after 30 seconds.
Ooh, I don't think I have anybody
I got
else.
66.5. I quit.
Is it round?
No, it's
I
fine.
got 66.5.
And it just goes 5.
Yeah, I got 5.
No.
Okay. 66.5 is a fine way to round it. It's okay. That's the average height.
I got 66.5. That's
Cool.
Good
job. Good job. Alright, so you don't typically have that many data points, but I thought it would be interesting to do that. Do you guys know what you call the kind of numbers that are way further out from the
I forgot a number.
outliers? Yeah. So when they're a lot smaller or a lot bigger than the average, it's called an outlier. Alright. Our next word is variance. Right? The variance is a measure of how spread out, let's use spread out, how spread out data is. A measure of how spread out data is. So if you were to graph all of those little values that we found just now, they would all be clustered pretty close together, except for what we were talking about, the outliers, right? So the variance is a measure of how spread out your data is across a number line if you were to graph them all. The symbol for variance is sigma, but lowercase. Right? All Greek letters have uppercase and lowercase. This is the lowercase sigma. Right? I usually draw it like that, like a inverted circle type thing. It's like a O with a hat on it. The symbol is sigma, but this is the formula. You do not need to remember this. Right, I'll tell you why in a second. That's the formula for variance. Just see it and then be like, ooh, ah, and then move on from it. Alright, so using the formula for variance is actually going to give you inflated numbers. When you use variance, they give you a number that's too big. They do represent how spread out the numbers are, but because there's a square here, that's going to inflate too much to make it relevant to us. So what we're going to do is we're going to use a variation of the variance to get a more useful measure of data spread. So instead of using variance, we're going to use what we call the standard deviation. That should sound familiar. You guys remember standard deviation?
Yeah.
So a standard deviation, the definition of that, more specifically, it measures measures data spread from the mean. Data spread from the mean. So this is still telling you how spread out your data is, but it's using the mean as a reference point. They're saying, here's the mean. How spread out is your information around the mean? Is it clustered close to the mean, or is it spread out far away from the mean? That's what we're going to find out using the standard deviation. Now, the same symbol is used for standard deviation, but what's the difference between this formula and the one up there? So they took the square root. So in order to go from variance, which was too big of a number, they square root that. That gives us the standard deviation. Right? So the standard deviation is basically the square root of variance, and this gives us a more meaningful representation of the data spread. Again, you guys don't need to know the formula. Right? That's just to look at and understand the difference between variance and standard deviation. Again, your calculator's going to do the work for you. Right? You don't ever have to number crunch for finding standard deviation. We're going to let our calculator do it. So let's go back to the information you had in the first example, the smaller set. Go back to set edit. Go back to the original set of numbers we had. The 4, 36, 10, 22, 9. The smaller set, just 5 numbers. Then you're going to go back to stat calc, the same screen we did for the mean. Stat calc and then 1 var stats. The standard deviation is this guy right here, the one that has a little OX type thing right there above the N. So the standard deviation would be 11.5. That means, on average, your points are 11.5 away from the mean. That's how you would interpret this number. This number tells you how far your numbers are on average from the mean. So if you have your mean here, like right here, that means your points are like 11.5 away from the mean on average. That's what standard deviation represents. Okay? So again, no number crunching, just let your calculator do the work. You're just going to plug the numbers into the calculator. So what we're going to do is we're going to talk about these 3 different sets of data. We're going to do some comparisons. When you guys are talking about mean and standard deviation, they're going to be asking you to compare things, to interpret or analyze data based on the mean and standard deviation. So what I want you guys to do is for each one of these data sets, I want you to find the mean and the standard deviation separately. Okay? So try this one. Let's do them one at a time. We're going to do this one, find mean, standard deviation, and then reset. So for this data set, I want you guys to plug that into your calculator. Find the mean and standard deviation. In your calculator. Right, does anybody have the mean for this first data set? It's 30. And what's the standard deviation?
600.
Okay, cool. Alright, when you guys try it for the next set. Yeah, we use our calculators a lot too. Alright, the mean for this set. So 30 again, and then the standard deviation 7.1. Alright, then the last set.
30.
Yep. The mean is 30 again, but you're gonna have a different 8.9. No.
No.
Never
Always
round.
have it.
Always decimals. Yep. Alright, so here we have data sets that have the same mean but different standard deviation. So what we're going to do is we're going to create what we call a dot plot to represent the data to understand what the different standard deviations mean visually. Okay? So to create a dot plot, you're just going to create little X's or dots for each data point. So for 20, I would create a little X or a dot for that data point. I have 3 30s, so I'd write 1, 2, 3 to represent each, and then 140. So I have this. Right? Then for the next set, I have a 20, then I have a 25. How would I represent the 25?
In the
In the middle here. Then I have a 30, and then a 35, and then a 40. And over here I have 2 20s, 1 30, and 2 40s. Alright, so let's try to look at this visually and understand what the standard deviation indicates based on the pictures here. Alright, so for this one, this has the smallest standard deviation, right? Remember, standard deviation tells you how far out your data has been spread from the mean. You guys look here, aren't the majority of the points at the mean? The mean was 30. Don't we have most of the points here and only a few further out? That's why this one, compared to the other pictures, this one has a smaller standard deviation because most of the points are near the mean, right? This one, you only have 1 point near the mean, and the others are spread out, but they're not spread out too far. See how they're spread out kind of evenly? The 25 and the 35 are still relatively close to the 30. That's why this one has a slightly bigger standard deviation, but it's not as big as this one, where all the points have been thrown away from the mean. So that's how you guys can interpret the standard deviations. How far away are the majority of your points from the mean? The more spread out they are, the higher the standard deviation. The closer they are clustered to the mean, the smaller the standard deviation. Okay. You guys do need to know how to interpret standard deviation and understand what these small versus big means. Okay. All right, we're going to try a standard deviation question using people's first names. So you guys need to count up how many letters are in your first name, full first name, not nickname, and then we're going to write that down just like we did for everybody's names. Okay, so think about your name, your full name, and remember how many letters are in your first name, your full name.
Just first name, not full. First and the last.
Your full first name, not a nickname if you go by a nickname.
So acid sauce is So wait.
Mine's 9.
Yeah.
Mine's 9. Alright, so that's going to be our first data point. Alright, we're going to go around the same way. Anthony. 7. Cool. Right? 5. 9.
6.
Okay. 5. 3.
5.
5. 6 again. Right.
Number 6.
6.
6.
Okay. I think we know what the mean is. Jonathan? 3? Oh, right. Huh. Okay. 7. 4. 6. Ooh, I moved the board. Sorry.
I wrote 3. It's in there. Wait, which name?
Your first name.
Actual real name?
Yes.
Six.
Alright. 5.
6.
Alright, once you have all the data written down, we have 2 extra, then we have boxes. I want you guys to enter that into your calculator, find the mean and standard deviation. Is it 6?
6 and 1.6.
1 point.
6. It's 1.5. It's 1.55. But 5 is
Then it rounds to 6. So the average length of somebody's name is 6. standard deviation of 1.6. What does that mean? Yeah, it means that our lengths are relatively close to 6, right? They're not too spread out. We don't have like 15, somebody's name is 15 or something like that. We're all really close. Another way that you can say this is on average, the names are 1.6 away from the mean. That's a way that they could express it, using the on average kind of language there. I'm going to describe that at the bottom so you guys can see that. Alright, I want to talk about what standard deviation means. I want you guys to physically write it down so you can have that documented. So standard deviation is the best measure of how varied or spread out data may be. Oftentimes we express the level of variability in terms of consistency. So if you guys have a small standard deviation, what do you think that means about consistency? The data is very consistent. The data is very consistent. 7E, I don't know how to spell that.
Yes.
Okay. So if your standard deviation is small, that means that they're all clustered really close to each other in the mean, so that means that the data is very consistent. What does it mean when the standard deviation is big? It's not consistent, right? The data, I'm going to say, is less consistent. So the bigger the standard deviation, the weaker the consistency, right? What do you think it means when the standard deviation is exactly 0? All the numbers are the same, but what number are they?
0.
Not 0.
1. Negative.
The mean. It means that all the numbers are the same and they are the mean, right? So all numbers, all data is the mean. If your standard deviation is 0, that means that your points have not gone away from the mean, so that means they all are the mean. Right? So 30, 30, 30, 30, 30, 30, 30, all the same number and they all happen to be the mean. Okay? So we're going to look at this data set. I want you guys to tell me which one has the highest variability or highest consistency. So we're going to need to find the mean and standard deviation for all of these and figure out which one is most consistent. So you guys are going to go back into your calculator. You can use the list 1, list 2, list 3 if you want to. Otherwise, you can just delete them and reset. I'm using list 1, list 2, list 3. You have to tell the calculator which list you want, which may be a little bit complicated. So maybe easier to just erase and start over. So go ahead and find the mean and standard deviation for each. You can tell me what the mean and standard deviation are for the first set. Okay. Who has the mean and standard deviation for the next set? Here. 7, I think it rounds to 7. And then 4.4. What about the third set? I think it rounds to 12.7. Alright, so I have 2 questions for you guys. Which one of these data sets has the higher mean? List 3. Alright, because list 3 has the highest mean of 12.7. You should notice that they all have different means and different standard deviations. The mean has no impact on the standard deviation. Right? They don't have to have the same mean for you guys to compare standard deviation. The standard deviation is a measure regardless of what the mean is. It's just talking about how far the points are from that specific mean that you would have found before. So if I ask you which set of data has the most variability, so that means the most variable. Which one is most varied? It would be, yeah, list 2. Most varied means that it's more spread out. Varied means different. If you guys don't know that word. Varied means different or kind of not similar. I mean, that means the same thing. So when they're asking for the most variable set, they're talking about which one's spread out the most. And how do you tell which one's spread out the most? The higher standard deviation. We usually abbreviate standard deviation as SD. So if you see that, that's what that means. Alright, so they ask you for the most variable or least consistent. That's a little bit confusing. They say most variable means the same thing as least consistent. Maybe write that down, might be helpful. Least consistent. Right, consistent and variable are antonyms. They're opposite of each other. So most variable means least consistent. Alright, and you would want the higher standard deviation. Alright, so some terminology you guys need to be aware of. These are 2 different ways that they're going to ask you about the standard deviation. They always use this language, the on average thing. So whenever you see that, that's a good indicator they're talking about standard deviation. So on average, how far the data is from the mean, that's another way of expressing the standard deviation, right? And then how much older, higher, etc., whatever they're talking about in the context, something is on average than the mean. So those are 2 different ways they can express a question. They will not just say, what is the standard deviation? You're never going to see something like that. They're going to bury the question in this terminology, so you guys need to understand that. When they ask about how far something is from the mean, on average, they're referring to the standard deviation. Okay? Does that make sense? That's our introduction to the subject. Alright, any questions? That's it. So we have plenty of time, so I'm going to leave it up to you guys. You can probably knock out the homework, and then you have plenty of time to finish the graded assignment, get it checked if you haven't yet. So you're going to use the time now to work on the homework or the graded assignment, whichever one you guys need to finish. Yes, you can listen to music, that'll help you focus. But since you have so much time, I expect the graded assignment to be done before you guys leave. Alright, so if it's not done, please work on that so it is. 1 second, let me finish the recording.